Hi class, how's it going? Mr. Mulcahy from the floor today. Today we're going to talk about the wheel and axle. The wheel and axle is the last simple machine, and it's something we're all familiar with because we see wheels all over the place. So what exactly is a wheel and axle? It's basically a wheel attached to a cylinder. So in this case right here, I have a wheel and it's attached to a cylinder. And as the cylinder turns, the wheel turns, okay? And that's the simple concept of a wheel and axle. But there's a couple of things we need to know about it. Then we're going to talk about some examples that in everyday life that you might not think about that, oh wait, that is a wheel and axle, okay? So, but the thing we've been talking about again is mechanical advantage. Because the mechanical advantage is what helps you in regards to using less effort to create the same amount of work. So for a wheel and axle, right here, mechanical advantage, first of all, a wheel on a cylinder, mechanical advantage is the radius of the wheel divided by the radius of the axle, okay? So what exactly does that mean? So let's look at some of these examples I have here. So here I have a wheel and here's my axle. So if I were to take the radius, which is basically from the center to the outside, and divide it by the radius of the axle, that would give me my mechanical advantage. You could also use diameter divided by diameter because radius is half a diameter, so it would work out the same way. So what happens here is basically if the thinner the axle, the greater the mechanical advantage. Okay, so I have a bunch of different examples here. So here's one, here's another one, here's another one, here's one with a toothpick as the radius, as the axle, sorry, and then last one. Okay, so I have 5 different examples here. So the question is, which one would have the greatest mechanical advantage? So think about it this way. So here, my axle is almost the same size as my wheel. So watch what happens. Watch the blue mark. As I turn it to get it one full turn, you know what? That has to turn that far. So I'm not getting that much of an advantage doing this because, or in regards to the effort I have to give. Because again, if you look, it takes the same. Now let's go to here. So now this one has a smaller axle. So watch what happens as I turn it. I didn't have to go, it was easier for me to turn it, okay? So now watch what happens when I go smaller. So now this axle. Here I have an axle and watch what happens. Boom. So I'm turning it once and it's spinning around. So as a result, to get to the mechanical advantage is greater here, and you'll notice how much quicker it spins because I don't have to turn as much. Okay? Then I go to my pencil here and voila, I turn it once, and lastly, the paper clip. Boom. Boom. Very easy. So you'll notice that all the wheels were the same exact size. The only thing I changed was the size of the axle. So the one that had the greatest mechanical advantage would be this one. And I didn't calculate it out, but it'd be extremely high because look at the size of the toothpick compared to the whole the wheel. And that's why it's so easy to turn. Okay? And again, we use wheels all over. You know, when I grew up as a kid, you know, luggage you had to carry. But now, everything luggage is all on wheels. You have a wheel and axle, okay? And the reason why it makes it so much easier is because now you're not just dragging it or carrying it. The wheel, the mechanical advantage of the wheel is great. So as a result, it makes it so that you have to exert a lot less effort to do something. Now let's think about some examples in our house. The first example I always think about is a doorknob. I was going to take a doorknob off my door, but my wife was like, "You're not touching the doorknobs!" And I was like, "What do you mean?" So I was like, "Okay, I won't use that." But a doorknob, the doorknob itself is the wheel, and inside it there's an axle, and that's what turns the little thing that goes in and out that opens the door. So when I was going to take off my doorknob, I was using a screwdriver. And guess what? A screwdriver is a wheel and axle. And you say, no, it's not. No, but it is. Think of it this way. The handle would be the wheel, and the axle would be, the rod where you're, attached to the screw head. Okay? Now, think about this. If you've ever used screwdrivers, it's a lot easier to use a screwdriver that has a bigger handle. Okay? versus one that has a medium-sized handle or a smaller handle. The smaller handle one is a lot harder to use. You really have to work here. Now this one, you're turning more, but it's a lot easier. Let's think about it. Mechanical advantage. The radius of the handle versus the radius of this. So as a result, the ratio is bigger. Whereas on this one, the ratio is a lot smaller from the rod to the handle, okay? So that's an everyday thing, or two everyday things that we use all the time that are wheel and axles. Lastly, I just want to mention, there are situations where you have something called a gear, okay? And a gear looks like a circle with little, it has wedges on it, okay? And there are situations where, if I was in class, I would be showing you an egg beater. An egg beater has a gear attached to the axle, and the wheel is a big gear. And the way you would figure out the mechanical advantage of a situation like that, where you have two gears, it would be the number of teeth on the wheel versus divided by the number of teeth on the axle. And that's how you would figure out the mechanical advantage of it. So again, it looks like a wheel, but it has little wedges on it, and those are called teeth. Okay? So if we were in class, I would be showing you an egg beater, but unfortunately I don't have one at home. Okay, so this is our quick little lesson on the wheel and axle. Okay? Enjoy. I hope everyone's doing their best to stay safe at home. And this is the end of our little lessons in regards to the 6 simple machines. Okay, I will see you when we get to our next topic will be light. Okay, have a great day. Bye now.